Hello friends, today we will have a look at another type of problem. Now there is a problem in which we find that there is some data missing. In this problem over here we have been given the following data is of a closed traverse. Compute the missing quantities. The line AB length is not given. The whole circle bearing is 45 degrees 00 minutes 00 seconds. For the line BC length is 500 meters and the whole circle bearing is 120 degrees. For the line CD, length is 450 meters, the whole circle bearing is 240 degrees, and the last line of the traverse, we don't have the length, but the angle is 300 degrees. Now, when does this happen that we don't have the lengths? It may be that the chaining is not possible, but finding the angle was possible. It could be a case of maybe there is a pond or a river in between the two stations, because of which finding the length is not possible. So maybe there are two lines of which the lengths finding was not possible. Finding the lengths was not possible, but the angles are given, and it has been told to us that it is a closed traverse. Now if it is a closed traverse, we are supposed to find the length AB and the length DA. Please note one thing, in such type of problems there is no check to find if there was a error of closure in the traverse. That is a closing error. If there was, we cannot find, because one or more than one quantities were missing. So we just assume that there is no closing error and we go ahead. Uh, the only assumption which we take in this, do in this, is that all the lengths and all the angles have been accurately found out. So when that accuracy is there, we can go ahead and consider that it's a perfectly closed traverse without any error, and then we can find the quantities. Also please note, we can find out only if one or two quantities are missing. If it is more than two quantities missing, then it is not possible with this type of uh, data to find out the missing quantities. So maximum, if there are two quantities missing, we can find them. Now in this case there are two lengths missing. Let us see the procedure of finding the two missing quantities, that is the two missing lengths. Going ahead, the step 1 is calculate the latitudes and departures of all the lines, all the given lines, all the four lines, and assume the unknown quantities as L1 and L2. So for the line AB, the length is assumed as L1, whole circle bearing is 45 degrees. The latitude of this line is, we know that latitude, the formula is L cos theta. Latitude is equal to length into cosine of that angle. So over here the length is L1 into cosine of 45 degrees. So we get the answer over here as plus 0.707 or 7071 L1, since L1 is not known. Let us look at the departure. The departure is given by the formula L sine theta. Departure is given by the formula departure is equal to length of that line into sine of that angle. So length of the line is L1 and sine 45 degrees. So over here I get the answer of the departure as plus 0.70771 L1. Coming to the line BC, length is given as 500 meters. The whole circle bearing is 120 degrees. The latitude is, as we know, the length into cosine of the angle. Since the length is 500 and angle is 120 degrees, it is 500 cos of 120 degrees. The answer is minus 250 degrees. Sorry, minus 250.00 meters. Please note, the latitude is negative, means it's southing. Southing is 250.00, or latitude we can easily say that it is minus 250.00. Coming to departure, departure is given by length into sine of the angle. Since the length is 500 and angle is 120, it is 500 into sine of 120. The answer is plus 433.01. Now this shows that it is easting, it is in the east direction. Coming to the next line, the line CD, Length is 450 meters. The angle is 240 degrees. The latitude is L, that is length into cosine of the angle. So length is 450 into cos of 240. The answer is minus 225.00. Minus shows that it is southing. It is southing 225, or the latitude is minus 225.00. Departure. The departure is calculated as length into sine of the angle. Length is 450 and sine of 240. We get the answer as minus 389.71. This means that it is westing. For the line CD, we have westing 389.71 or departure equal to minus 389.71. Coming to the line DA, the length is assumed as L2. The angle is given as 300 degrees. So we have this as L, that is length into cos theta. So L2 into cos of 300 degrees. So we have this as plus 0.5 L2. The departure length into sine theta. Length is L2, sine of 300 degrees. So we get that as minus 0.866 L2. Okay, minus 0.866 L2. That means it is westing over here. So this way we have calculated all the latitudes and all the departures. Please note that L1 and L2 appears in the latitude, L1 and L2 appears in departure also. Now after doing the step 1, that is calculating the latitudes and departures of all the lines, let us go to the next step. The next step, step number 2, is obtain the sum of all latitudes and their departures separately. So this value plus this value plus this value plus this value will be giving me sum of latitudes. So sum of latitudes is 0.7071 L1 minus 250 minus 225 plus 0.5 L2. Finding the sum of all latitudes. Now finding the sum of all departures, that is 0.7071 L1 plus 433.01 minus 389.71 minus 0.866 L2. So in this way we have performed step 2, that is obtain the sum of all latitudes as well as that of all departures. So we have got all the latitudes, we have got all the departures as the sum. Let us move ahead to step number 3. In step number 3, the sum of all the latitudes as well as that of the departures individually respectively should be equal to 0. That means whatever we have taken over here, that should be equal to 0. So what we have taken over here, we are putting it equal to 0, and solving for the numbers, we get this as 0.7071 L1 plus 0.5 L2 will be equal to 475. That gives me equation number 1. When we solve this, we have 0.7071 L1, then 0.5 L2. These two numbers come together, they go on the other side, that becomes 475. That is my equation number 1. Coming to equation number 2, departure equal to 0 equal to the whole set which we had taken earlier. So 0.7071 L1 and minus 0.866 L2 remains over here. This is a number, when we solve and we take it the other side, we get the number as minus 43.3. So we get this as plus 0.7071 L1 minus 0.866 L2 is equal to minus 43.3, and that is my equation number 2. So from latitude I have got equation number 1. From departures I have got equation number 2. Please note one thing. From latitudes I have got two variables, that is two unknowns, L1 and L2. From departure also I have got two unknowns, that is L1 and L2. I have two unknowns and I have two equations. So having two unknowns and two equations, I know that mathematically they can be solved. Two unknowns and two equations can be solved easily. Let us look at step number 4. Solve equation 1 and 2 simultaneously to get the values of L1 and L2. We can use any of the methods. We can use them as simultaneous equations also in order to solve and get the value of L1 and L2. So we are putting them as plus 0.7071 L1 plus 0.5 L2 is equal to 475 and plus 0.7071 L1 minus 0.866 L2 is equal to minus 43.3. So if we change the signs over here, make this minus, make this plus, and then this plus, this will get cancelled. This can be solved. This can be solved, and we will be having only one unknown, that is L2. That value of L2 we get it as 379.43. Substituting the value of L2 in any of these equations give us the value of L1. That is, L1 comes as 403.46 meters. Having solved this, we have got the answer. The two unknowns we have got, one is L1, which is 403.46 meters, and L2 379.43 meters. That's the answer. Thank you.